Hello people, almost off-grid Dave here, aka Captain Dave, and this old fella down here, he's my best mate Wally. So I thought I'd do a little video on the off-grid power system at the homestead. I'm going to do it in two parts, and both parts will be in this episode. Part one will look at the system as it is today, and I'm about to do a battery upgrade, which I'll do in another video. Part two, I'll go through the evolution of my power system from when I first got here 15 years ago, and yeah, we'll go from there. And the first thing I'm going to do is just go through the schematic, so that's the plan of the system before I built it, and just explain what parts are in there and what have you. So onto the schematic. Okay, so here we are at the schematic. So we'll start at the battery. Here is the battery. I currently run a Power Plus Eco 4840p lithium iron phosphate battery. It's a 4 kilowatt hour at 48 volts. Self-managing, so it doesn't need any particular data connection to the main system. However, the system is programmed to the parameters Power Plus provide. So pos and neg come out of the battery into a 2-pole isolator. Then we have a main fuse in the positive line and direct connection to the positive buzz bar. The negative line comes out of the isolator to a shunt, a Victron shunt, and the system side of the shunt connected again to the negative buzz bar. Excuse me. 2 inverters. We have a master and a slave. They work in parallel. Direct connection to the negative buzz bar on the negative side, and connection via a fuse for each inverter to the positive buzz bar. So when we go to the solar array, I have a 9-panel system on this PV charger. There are 3 strings of 3 panels in parallel. That gives it about 110 volts open circuit, or about 80 to 90 volts maximum power. There's a double pole isolator on each string, a separate circuit breaker for each string, so 3 circuit breakers, and then to the input of the PV charger, which is a Victron Blue Solar MPPT 15035. So it's 150 volts input at 35 amps output. So out of the MPPT we have a double pole circuit breaker, inline fuse in the positive line, and then we go to the buzz bars, pos and neg. So over here on the right hand side we have the Servo GX. That's kind of the brains of the system. That connects the data from the MPPT, the 2 inverters and the battery monitor, B&V 700 together. and also provides online monitoring. So I can actually log on to the internet or my network and see what's going on with the power system. BMV 700, that gets its information from the power shunt and the positive feed. So it looks at the voltage and the current going through from or to the battery, and it will give us a state of charge, power in, power out, whatever. So a good thing to have. Now on the main side, the 230 volt side, we have each output, each inverter coming down to an independent circuit breaker. They're common on the system side and then disappear into the consumer unit here. The backup generator. So we have a backup generator which can be used either just for charging or for power assist. So if I need a few more watts out of the inverters, I can fire the generator up and it will assist the power. So he disappears into the consumer unit via a circuit breaker, comes back out. There's a double power point and then two leads that go into, or lead that goes into each inverter. So that's a basic rundown of the system. So we'll go and have a walk and have a look at the physical system. Okay, so we'll take a little walk out to the power shed. A little bit cloudy today, but we've had a fair bit of rain, 10-15 mil. But, still getting good power into the solar array, so that's all that matters. Okay, I'm just going into the power shed now, and here we are. So I'm going to turn the camera around. So we start at the battery. Main power lines from the battery go to the isolator switch. From the isolator switch, the positive line goes up to buzz bar via the main fuse. The two outer fuses, the inverter fuses, one to the master, one to the slave. Okay, the negative line on the left hand side of the isolator goes down to the negative buzz bar here, and below that is the Victron DC shunt. Can't really see it that well, but there it is. That's the DC shunt there. Okay, so then we got our master inverter and then our slave inverter. On the PV side, the solar panels, we've got the MPPT 15035. To the right of that is the 3 circuit breakers for isolating each string. And coming out of the MPPT, we're going to have our double circuit breaker for isolation, and then just an inline fuse, which then goes to the main buzz bar. Right, now the Servo GX, I've just installed that. I used to have a Raspberry Pi running Venus OS, which is Victron's operating system. But I replaced it with the Servo because the Servo can talk to the new batteries when I get them. So hooked up to the shunt is the Victron BMV. It's currently indicating the voltage. I can scroll through that, and the battery's sitting at 61.4%, and it's 7:45 in the morning, so it's not too bad. This is hanging loose because it was mounted in a box and I've got to make another enclosure up for it. So mains wires, All the mains output is running conduit up to a consumer unit. So there we have the two inverter circuit breakers on the left hand side. The right hand side circuit breaker is for a grid tie inverter which is hooked into the system. That's there just to help the solar part of it on cloudy days. The relay there is to cut off the grid tie inverter if the DC bus voltage gets too high. It's just a sort of protection thing. So I don't want to cook the batteries, they're not cheap. Right, so that's, if I can get a shot here, but so yeah, that's about the best shot I can get there. Right, okay, we'll try that. Okay, so welcome to part 2, evolution. This is the evolution of the power system. So I started out just with a small power system in the bus. I managed to get a late 90s UPS uninterruptible power supply. It was a good brand Eaton, 1.5 kVA at 24 volts. I installed the unit in one of the boxes under the dinette seat, and behind it you can see a couple of 120 amp hour 12 volt batteries, sealed lead acid. The front panel I managed to attach on the outside of the seat box so as I could turn it on and off without opening the lid. So after a year or so of using the system in the coach, I decided I should centralise the power system and build a little shed. So that's I went about building a shed. There's 4 posts concrete in the ground with a false floor and a 22-degree angle for the solar panel roof. I then got some second-hand roofing iron to clad the walls and then put a timber front on it and a screen door. For the storage I used Trojan T105 batteries. They're a 225 amp hour 6 volt battery, and I had 8 in series to make 48 volts. To charge the batteries I managed to get hold of an old telecom rectifier unit which plugs into a generator and then can charge the batteries, and it's a fully adjustable voltage and current rate, so it's good for charging lead acid batteries. Now for the inverter I bought a power jack inverter. These were quite readily available on eBay, and I looked into if they'd been reviewed, and there was a lot of people reviewing them saying they were quite a solid inverter, but they needed substantial modification to be reliable. They came in an aluminium enclosure which everything was like jam packed in there, as you can see in the video, in the photo. So I went down the dump shop and found a suitable enclosure, industrial enclosure, and we took the guts out of the aluminium box and put them in the new box. Some more fans to keep the cooling going, and on the front panel I put a couple of temperature gauges so just monitor the temperatures of each bit. Okay, so the next 5 years went swimmingly, but then after that time the Trojan batteries started failing, and then disaster. The power jack had a catastrophic transistor failure, and that was it. I was back to using the system on the coach. That point I decided I was going to buy something decent, so I went with the Victron system and the Power Plus Eco 4840p battery. And again, everything's been good since, so hopefully it'll carry on that way. So that's a brief history of my journey over the last 15 years. Would I do anything different? Well, I probably couldn't due to financial constraints. I was just lucky that I could actually afford to replace those parts when I did. So anyway, until the next video, cheers.
Hey!